For centuries, humanity watched things move, things fall, planets orbit, but we never really knew why. It was this huge, fundamental mystery. And then, one guy, Sir Isaac Newton, came along and basically handed us the rule book for the universe. So today, we're going to dive into his 3 simple but incredibly powerful laws that literally move our world. And you know what? It all started with a pretty simple question. I mean, we all know an apple falls from a tree, right? But the same force pulling that apple down is also pulling on the moon. So why doesn't the moon just come crashing down into the Earth? That one simple question sparked a revolution in science, and it's the mystery we're going to unravel right now. Now, you might think a breakthrough like this happened in some bustling university lab, right? Nope. It actually happened during a time of total isolation. The Great Plague hit back in 1665, and Newton had to leave college and go home. And it was there, all by himself, that he laid the groundwork for pretty much all of modern physics.
Kind of amazing.
All right, so let's jump into his first law. The best way to think about this one is it's the universe's default setting. It's the fundamental stay-put rule. We call it the law of inertia. Okay, the official definition sounds a little formal, I know, but the idea behind it is huge. It basically says that objects are, well, they're kind of lazy. They won't start moving or stop moving or change direction all by themselves. Something has to come along and give them a push or a pull. So to put it super simply, things just keep doing what they're already doing. But wait a second, that sounds wrong, doesn't it? I mean, if you roll a ball on the floor, it eventually stops. But that's only because of things like friction and air resistance. If you were out in the total vacuum of space, with no friction at all, an object you pushed would just keep going, in a perfectly straight line, forever, unless something else got in its way. And you see this law in action everywhere once you start looking for it. A football sitting on the grass, it's not going anywhere until someone kicks it. A spaceship deep in space with its engines off, it'll just keep coasting forever. Oh, and here's a good one. Next time you're in a car that slams on the brakes, you feel that lurch forward. That's not the car pushing you. That's your own body's inertia trying its best to keep moving at 60 miles an hour. Okay, so the first law tells us that stuff resists change. So the next logical question is, how do we actually make things change? How do we get them to move or speed up or slow down? Well, that brings us right to the second law. You can think of this one as the push-power rule. This is the real engine of change in the universe. And it comes down to this super simple but crazy powerful equation. F equals ma. Force equals mass times acceleration. This might be one of the most important equations in all of physics. It's way more than just a formula. It's the actual mathematical blueprint for how to make things move. So let's break that down. All it really means is that the heavier something is, the more mass it has, the more force you need to get it to speed up. It's why it's easy to push a bicycle, but trying to push a truck is, not so easy. And it's why rockets need an absolutely insane amount of force to lift their massive weight off the ground. More push gets you more speed up. Simple as that. All right, so quick recap. Law 1, things like to stay as they are. Law 2, here's the math for how to change them. But what's really going on in that interaction? Well, that brings us to the third and final law, and honestly, this one is maybe the most elegant of them all. This is the universe's pushback rule, and it shows us this beautiful, hidden symmetry in everything. You've definitely heard this one before. For every action, there is an equal and opposite reaction. What that really means is you can't push on anything without it pushing back on you with the exact same amount of force. It's a universal rule. Forces always, and I mean always, come in pairs. And these action-reaction pairs are everywhere. Think about a rocket launch. The rocket isn't just going up, it's violently throwing hot gas down, and it's the gas that then pushes the rocket up. Same with a bird. It pushes air down with its wings, and the air pushes the bird up. And get this, even when you jump, you're actually pushing the entire planet Earth down a tiny, tiny bit, and the Earth is pushing you up. Okay, so we've talked about cars and birds and rockets, but here's where Newton's genius really shines. He realized these aren't just rules for stuff here on Earth. No, these are the rules for the entire universe. These 3 little laws, they explain why the planets orbit the sun. It's this perfect dance between their inertia, which wants to fling them out into space, and the sun's gravity, which keeps pulling them back in. These laws explain the ocean tides. They explain how we keep thousands of satellites in perfect, stable orbits. And yeah, they are the absolute core principles behind every single rocket that NASA or SpaceX has ever launched. So, why does any of this 350-year-old science matter to you, right here, right now? Because I promise you, these laws are not just stuck in old textbooks. They are the invisible blueprint that our entire modern world is built on. I mean, take something like video games. Ever wonder how the physics in a racing game feels so real, or how a character jumps and lands so believably? That's all Newton. That's F equals ma. Programmers are literally using these laws to code how everything moves and interacts. His laws are the operating system for those virtual worlds. Not to mention, they're crucial for designing safe cars and building skyscrapers that don't fall down. Just think about that for a second. For over 350 years, these laws have been the bedrock of our technology. To have a scientific idea last that long and still be this important, that is just incredibly rare. And what's amazing is that Newton himself was pretty humble about it all. He famously said, "If I have seen further, it is by standing on the shoulders of giants." He knew he was building on the work of the brilliant minds that came before him. But today, the script has completely flipped. He's the giant now. Every single engineer, every physicist, every video game programmer, they are all, in one way or another, standing on the shoulders of Isaac Newton. When you boil it all down, these three simple laws gave us a universe we could actually understand, a universe that was predictable. They took us from a world full of mystery to a world of engineering and space travel. So it really makes you wonder, right? What's the next fundamental rule of our universe that's just waiting out there to be discovered?